watch it. All right. So I gave you this note sheet yesterday just so we had something to look at here. Mr. Samuelson, story time, reading you the first sentence. I'm not going to read you the first one. You can read that already. It's this one that matters. What is a vector? And all it is something that has both magnitude and direction. And the magnitude would be like velocity. That's really the one I'm going to talk about the most. Acceleration of some sort of force. We're going to talk about forces, two forces acting on an object. You physics people will remember this. It's pretty simple. And it does relate to trigonometry. That's why it's inserted in 7.4 and 7.5. Um, so the magnitude, here's what happens, right? And this is what we do with stuff, in order to so that we can put it on paper and then make it translate to the real world. And I did do this with the other class as well. And I kind of want to share this and actually talk about like an airplane. An airplane, let's say, travels 500 miles per hour. For some reason, people got this lock on uh, bearings, just can't figure them out. And I don't know what the problem is, but we'll just keep trying to get you to figure this out. So the bearing of it is north 45 east. So here's what we do with this vector. First of all, here's north. This is why this should not be rocket science. Here's east, and here's a 45-degree angle. So that's what the plane's flying on. And I actually talked with the other class about, a movie I watched. There's a 9/11 movie about a flight, I think 93. Oh, what a good movie. Really encapsulate what happened that day. But, part of it was an air traffic controller, and he's looking at this plane blipping on a screen. Well, that's a coordinate plane, everybody. That's what we do. We coordinate plane stuff to, figure out where things are in relation to the world. So here's a map. Here's a plane flying, maybe from Dallas to New York. I don't know if that's directly north 45 east. Don't know. But the length of this has meaning. So we're going to say that this is 500 miles per hour. That's the length. That's its vector magnitude. And then when the plane's flying up in the air at the highest point, there's a 20 mile per hour easterly directed wind. That's actually too large compared to 500. So we'd probably have to make that like this big. And that would be 20 miles per hour. And that wind is going in that direction, directly east. Well, everyone should know what happens to the plane then. What happens to the plane is it is kind of at its back, but it's also going to push it off direction. It's going to push it off of that direct 45-degree angle. So what happens in theory is this 20 mile per hour wind actually pushes the plane a little bit off of that 45-degree angle and actually makes it go a little bit faster. So this is the plane plus the wind vector, right? And that's how the computer figures out these things. That's actually called a resultant. Can anyone say resultant? All right. That's the resultant vector of the plane incorporated with the wind. So the computer has to, have that calculated in. So what the plane would have to do is go if New York was directly at a 45-degree angle to Dallas. Is that what I said? Yeah, those two. Then it would have to go a little off course on that to direct itself using the wind to get it to that position. So, you got to have an idea of what vectors are to be able to write the programming for those situations that help the plane do what it does. So I just wanted to give you that so that we could have some sort of real world connection to what a vector is. Its length has meaning and its direction has meaning. That's a vector. All right, we're going to simplify it and put a little simple coordinate planes and not planes, flying planes, coordinate planes, x, y axis. Don't want to confuse. There's too many planes in this example. Okay, so here's what we're going to do. We're going to simplify it. So vectors, we're going to actually put them in a coordinate plane. And we're going to call a vector by the endpoint that the vector ends at, where the tail is, where the arrow is. So anytime you see a vector in this format, it actually starts at 0, 0. It starts at the origin. And then A comma B is where the vector ends, right? And this is mostly what we're going to deal with, vectors in a coordinate plane. So really, it's going to turn out and come down to simple trigonometry. All right, so here's our first example. And I cut it and put it here sloppily with some of my old writing. Oh, I wanted to go back up here. Hey, look at your keyboard and look just to the right of the letter M. You see those two symbols. I don't know what those are called, and I feel terrible for not knowing what that's called, but that's the symbolism for vectors. Instead of a regular coordinate plane parenthesis, those symbols represent vectors, and I do have that right here, vector symbol, all right, where A comma B represents the endpoint of where they land. All right, so now I can look at number 19 and think about planes, maybe a little bit. And actually, we should know that -8, 8, ooh, this is great. That's north and that's west. So this would be north 45 west, huh? Wouldn't that be a 45-degree angle? Anyway, having a clue about vectors. Not sure why we're messing that up so much, some of us. But look at vector A. This goes by fours. So this is the endpoint, -8 comma 8, where that ends. And then look at vector B. That's 4 comma 8. That's where that vector ends. So that's how you would draw it, right? It's already drawn for you. But here's what A plus B is. Think about this as the plane situation. This plane is vector A, pretend, and it's going directly northwest. But then the wind is going in this direction. So it's going to push that plane off course if it doesn't account for it. So here's A plus B in geometric form. I'm going to rise 2, run 1. This is how you geometrically show A plus B. You tack B onto the end of A, and then the new vector is this. This would be the actual plane's course because the wind would put it off in that direction and actually make it longer because, again, it is kind of helping it in a way. So that is a longer vector, and this is at -4 comma 16. So I could do that just by counting the endpoint. Well, look how easy this is going to be. Where do you get -4 from? How about you just add the x's of those two vectors? And then where do you get 16 from? How about you just add the y's of those two vectors? There it is algebraically. So I showed it geometrically what happens, like in terms of plane flight, how one vector affects another. But really, it becomes grade school math in order to do it um, in that way. And I should do C first before I do B. What is the opposite of vector A? All it is vector A going in the opposite direction. So this is the opposite of vector A. So what is that endpoint? That is 8 comma -8. There's the answer for that. Well, look at how simple it is to find it from the original vector, which is just distribute a negative into the x and into the y. And then that's how you get 8 comma -8. So vector operations are really Mickey Mouse grade school stuff. All right, when we're talking about this stuff. So then what's A minus B? It's and that's what this was supposed to be, but I can't erase that. I got it from an old thing. So that used to say A minus B is really the same thing as A plus a -B. Find -B and tack it on to the end of A. So that is the resulting endpoint. And it is this vector that is going directly west, ending at -12, 0. Well, look at this algebraically. It's so simple. Take -8 minus the 4. So you subtract the x's. Take the y's and subtract them. And then look geometrically, algebraically. Same answer. Mickey Mouse stuff. Next, since you already have that written in front of you, because I gave you this note sheet yesterday. Recap what we just learned. A vector can be named by the coordinate it ends at when placed in a coordinate plane. I typed this out myself with all these colors. The x coordinate is called the horizontal component. Come on, x goes right and left. That's horizontal. Y coordinate vertical, up, down. All right, here comes the trig. We will also ask you to find the magnitude, which remember is just the length. How long is that vector? That's it. And the direction angle. That is going to be coordinate trig. Don't freak out. It is the basics of chapters 1, 2, and 3. How to find these angle measures, perhaps using a calculator. So I might want to write those things down and really simplify this because it is. This is actually sophomore year trigonometry that we're going to be able to access in order to figure this out. So let's make you understand what's given in this first diagram. How can we find the magnitude and direction when we're given A and B? So I'm going to highlight what you're given. Pretend those are numbers. So we know what A and B is. How would I find in green magnitude and direction angle? So how would I find magnitude and direction angle? It is the most Mickey Mouse stuff you've ever used. So remember, you're given A and you're given B. Remember back in chapter 1, how do we draw triangles? We go X, then we go Y, and then we come back to the origin. But in this case, this is the vector. It's going in that direction with that length. Well, don't say you have a red triangle. You definitely have a right triangle. And I don't even want to see it in the chat because if we don't know this, this is problematic. We should know that a squared plus b squared equals, they're naming this vector's magnitude as u. So they just randomly pick the letter u. This happens all the time, and actually this is what you're going to have to remember for magnitude, u. Oh, by the way, squared. Then, of course, you square root both sides. Really, what you should put for magnitude of a vector is this. Okay, fine. I just came up with a new symbolism. Two straight lines around U means the word magnitude, which means length of that. But it does simply come from the Pythagorean theorem in simplified form. So that is the actual length of the vector. Now let's look at theta and talk about our sophomore year trigonometry. What side is this? Don't even bother to put it in the chat, but you should be saying it to yourself. And if you don't know the answer to that, you make me infinitely sad. Boy, is he mean in this movie. Opposite. And then what side is this? Adjacent. What trigonometric function deals with opposite and adjacent? Don't say cotangent. Say tangent because that's the one I have on my calculator. So tangent of theta would equal b over a. So how do I find this direction angle? Theta equals, of course, we should all know you take the inverse tangent of a ratio of sides to get an angle measure. So it's quite simple stuff to find these vector components from what is given. So I'm going to erase these. I was just showing you where these come from, these simplistic basic formulas. You could actually, I could have just said, how do you find theta? And everyone should have been able to tell me after what we've been through this year. Boy, we've been through a lot too, haven't we? Now, let us reverse things and analyze. How can we find AB given the direction angle and the magnitude? So now just reversing it. And then what we can do is work on this tomorrow with actually doing this. So now you're given those. Now we're going to reverse it. So if I'm given the magnitude and theta, how do I find the components A and B? Looks like I lost that. Given theta, I lost my theta in here. Oh boy, theta. How do I find A and B? Well, here we go again. It's the most basic of stuff. Let's focus on A first. What side is this? What side is this? What side is that? And the answer is adjacent. You don't know that? Get out. What side is this? It's the magnitude. No, opposite, adjacent, or hypotenuse. And the answer is hypotenuse. What trig function deals with adjacent and hypotenuse? If you don't know that, get Ouch. I don't know what you've been doing since January. Oh, is he mean? Is he mean? By the way, we should put u as like the two straight lines so we understand that that's the magnitude of u, just getting the formatting of what things look like. Oh, so what's a equal? All I need is a simplistic multiplying of the magnitude of u from both sides. So do understand, you're going to be given this and this. This is all I have to do to find this. All right, just insert those numbers. So then I'll get what the A component is. And then the B component, of course, is, hey, let's do it again because it's so much fun. What side is this? What side is this? That's the opposite. So for B, finding B, it's the sine of alpha, theta, sorry, is B over the magnitude of U. And then you multiply both sides by the magnitude of U. So it's real simplistic where these formulas come from. It could not be any easier. All right. So you'll see what we do with examples on this tomorrow. That's what we're going to go through. So then that'll give you time to do work in class. I do like that we've been doing that. So it worked out for you. Okay. Stop sharing. Let me just double check my attendance.